Dear friends, I myself, Dr. Bharat Parab, discussing problems on square of the number and square root properties. We have discussed theory of square of the number and square root properties, and we are trying to solve some problems. So see, this is a problem here, that find the square root of 169 and 225 by a repeated subtraction method. Okay, remember this repeated subtraction method. What is this? See here, we take 169 and we subtract all the odd numbers starting from 1 till you get 0. Okay, so we are starting 169 minus 1 is 168. From answer 168 minus 3 is 165, then minus 5 is 160, minus 7 is 153, minus 9 is 144, minus 11 is 133, minus 13 is 120, minus 15 is 105, minus 17 is 88, minus 19 is 69, minus 21 is 48, and minus 23 is 25, and 25 minus 25 is 0. As you get 0 here, 169 is a perfect square. Perfect square of what? How many digits or how many numbers are subtracted? You have to count these numbers. Okay, we have subtracted 13 numbers. So number of digits counted is 13. Hence 169 is 13 square. As simple as that. Okay. So very simple method. Okay, and we see it for 225. Now subtract 1 from, start from 1 and go ahead. Don't miss any number, or don't take even number, only subtract odd numbers. Okay, the 225 minus 1 is 224, minus 3 is 221, minus 5 is 216. Like that you go ahead, you come here. 104 minus 23 is 88, 81. 81 minus 25 is 56. Like that you go here. 29 minus 29 is 0. Okay, so you get 0 here. So 225 is a perfect square. So a number of digits counted is 15, hence 225 is 15 square. Okay, now here we need not even count the numbers. We need not even count the numbers. Okay, but subtract the even numbers we left. In this case, if it is here it is 25, then we have left 12 even numbers. Okay, that is we have 25 at the end to get 0, hence 25 minus 12 is 13 in the first case, and 29 minus 14 is equal to 15 in the second case. So this is this, and this is this. Okay, so here 13 is a 13 square, and 15 is a 15 square. Okay, so learn these tricks and your maths will be very easy. Okay, go ahead. So another problem, find the square root by prime factorization method. Okay, this is a method to find the square root, and prime factorization means you have to factorize this, and prime means you cannot factorize it again ahead. Okay, that is a prime factorization. So we take number 5929, root of 5929, we factorize this 5929. Okay, so as you see, there is no even number at the end, so no even number in unit place, so cannot be divided by 2. Now addition of all the digit is 25, so you cannot, this is not divided by 3, so this number cannot be divided by 3. Last 29 is not divisible by 4, so the number is not divisible by 4, as there is no 0 or 5 here, so it cannot be divided by 5. So try 7 and try successful. 7 5 and 2 9 divided by 7 is 847, again divided by 7 is 121, and we know this is very famous square of 11, so 11 is 11, and here 11 is 1. So factors of 5929 here, factors is 7 into 7 into 11 into 11. We write it like this, and to find the square root we take pairs. This is one pair of similar number, and is another pair of similar number. For this we write one number, and for this we write one number. So we write 7 for this pair and 11 for this pair. So root of 5929 is 7 into 11 is 77. Okay, so square root of 5929 is 77. Now another problem is 529, root of 529. We are again factorizing it. Take so this is about little different thinking. It is same thing, little different thinking. As we will come to know why this is different thinking, I will tell you. Now just see, this cannot be divided by 2 as there is no even number here. Addition is 16, so not by 3, and there is 29 at the end and not divided by 4. Hence this number cannot be divided by 4. No 0 or 5, so cannot be divided by 5. So if you go on thinking like this, that is a time consuming process. Okay, so we think in little different manner. Okay, so we see here 20 square is 400. Okay, and 30 square is 900, and this number lies between these two numbers. Why this thinking, I will tell you. Okay, so 529 lies between 400 and 900. Okay, so if it's a perfect square, then it's either 23 or 27, because 23 is the 3 square, you get 9 here only on this occasion. 23, 3 into 3 is 9 and 7 into 7 is 9. No other number between these two or any other number ending with 3 and 7 only give you 9 at the end in the square root or in the square, but no other number will give. And if number lies between 20 and 30, it will be either 23 or 27. Okay, why this different thinking is because I will come to that point, as only 3 and 7 squares have 9 at the end. Okay, so we see that 23 to 23 is 529. Hence root of 529 is 23. As 23 doesn't have any other factor, this itself is a prime factor. So going from 2, 3, 4, then 11, then 13, then 17, like that, that is a time consuming process. If had it been some number like no, higher number like uh, 83 or something, then that becomes a tedious job. So we have this thinking that if it is a perfect square, then it must be lying between these two, and this is a trick we use. Okay, that is why we have used this. There is no harm if you go ahead by taking 17 or 19 and like that, but that will give you answer if the number is very low. If number is very high, then this will not work, or it is a time consuming. Hence this trick is very important, that is why it is given here. Okay, so we see this root of 529 is 23. If this was not working, then we would have seen 27 into 27. Okay, got it? 27 to 27. Okay, then it will have been. Okay, we will come to know after solving some problems. Okay, so we move ahead. Another problem, different type of problem. Read it. Find the smallest whole number by which a number should be multiplied so as to get a perfect square number. Okay, what does this mean? Let us see. This is a number. This number is not a perfect square. Okay, then by what number it should be multiplied? You are trying to multiply it. okay, so that the new number will be a perfect square. To find it out, we have to carry out this method, similar method as we have carried out earlier by finding prime factorization method. Okay, so we will factorize this, we will find the prime factorization of this 2028. Okay, so divided by 2 is 1014, again divided by 2 is 507, divided by 3 is 169, then 13 is 13 and 13 is 1. Okay, so these are the factors of 2028. So we write it here. 2028 is equal to 2 into 2 into 3 into 13 into 13. Okay. Now this is a pair. This is a pair, but this 3 doesn't have any number to pair it. Okay. So if we multiply this by 3, then this 3 will also have a pair. So there will be 3 pairs, that is, one is this, another will be of 3, another will be of 13, and this 2028 which multiplied by 3, a new number will be a perfect square. Okay, hence we multiply by 3, we get all the pair necessary. So 2028 into 3 is 6084, hence 6084 is 1 this pair, another 3 and another 13 is 78. So 6084 is, which is root of 6084 is 78. Okay, so we have found out a number by which it should be multiplied so as to get a perfect square. Okay, another example, 768. So we find the prime factorization of this. So see here, 2 760 divided by 2 is 384, then again by 2 is 192, then 96, then 48, 24. So we have so many 2's and another 3. So we write it here 8 times, 2 into 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 3. So we have 4 pairs, but this 3 doesn't have any pair. So if we multiply this by 3, this number by 3, new number will be a perfect square because this 3 will also have a pair. Okay, find out what is the number and square of which number is this, or square root of this, the new number. Okay, that should be exercise 5. Okay, so we move ahead. Another example, read it properly. Find the smallest whole number by which a number should be divided so as to get a perfect square number. Earlier it was multiplied, now it is divided. Method remains same, everything remains same, only you have to divide in this case. Okay, we will see with this number 2925. So we carry out the prime factorization first. So we factorize this, 2925 divided by 5 is 585, divided by 5 is 117, then divided by 3 is 39, then divided by 3 is 13 and 13. So we write the factors. 2925 is equal to 5 into 5 into 3 into 3 into 13. So this is a pair, this is a pair, only 13 doesn't have any number to pair. So if we divide this by 13, then this will go, and we will have only two numbers or two pairs, numbers which are paired. So if we divide by 13, we will have all pairs necessary to form a square. Okay, so 2925 divided by 13 is 225. Got it? Very simple. Okay, hence root of 20, this is a new number which has formed, which is a perfect square. Hence root of 225 is 15 and 13. 5 into 3 is 15. Okay, another number 2645. So we divide this by 5 is 529 and 23 is 23 and 23 1. Okay, so 2645 is 5 into 23 into 23. So this is a pair. Naturally, if we divide this number by 5, you will get a number which is a square of this. Very simple. Okay, so 2645 divided by 5 is 529, and hence root of 529 is 23. So always multiply or divide those numbers which are not paired. Okay, answer is same for both. Method is same and answer is also same. In multiplication, you have to multiply by the number which is not paired. Okay, in this case this. Or in division also, you have to divide by the number which is not paired in this or this. Okay, so these are very simple. Only you have to see when to divide and when to multiply. Okay, try some problems and you will find it very easy. Okay, we will move ahead. We are trying to solve another problem. Find the smallest square number that is divisible by each of the following number. Okay, we are given a set of three numbers and we have to find a number which is divisible by all these three, set of three. In this case it is 4, 9 and 10. Okay, we will read it carefully and we will try to understand this. Okay, so 4, 9 and 10, let us try to find the LCM first. Okay, to find the LCM, we have to factorize this. 4 is equal to 2 into 2, 9 is equal to 3 into 3, and 10 is equal to 2 into 5. Okay, to find the LCM, we can take only one if it appears, similar number appears in two of these numbers, then we can take only one of this. We have to take only one of this. Okay, so we are taking these two, then these two remains, then these 3 and 3 and 5. So we are getting 180. Okay, now 180 is a number which is divided by or divisible by 4, 9 and 10. Okay, can get a number is called LCM only, least common multiplier. Okay, but this is not answer because we have to find the smallest square number. Okay, see, this is a square number we have to find out. Okay, and we know how to find a square number. If we have factors like factors of 180 are 2 into 2 into 3 into 3 into 5, then this is a pair, this is a pair. If 5 is a pair, then the new number will be a perfect square. Okay, so we have to multiply this by, we have seen this earlier examples, similar type of examples. If you multiply this by 5, then you will get a number which will be a perfect square. That is, for these two we get only 2, this 3 we get 3, and another pair it will be 5, it will be 30. So 180 into 5 it will be 900, and square root of 900 is 30. This is a perfect square, and 900 is that number. 9 is the smallest square number which is divisible by 4, 9 and 10. Okay, so got this? It's very simple. You need to think it and need to read this very carefully and try to understand what is asked and what is given. Okay, so moving to another problem. Second one, the numbers are 8, 15 and 20. The method remains same. First step is to find LCM. So 8 is 2 into 2 into 2, 15 is 3 into 5, and 20 is 2 into 2 into 5. You know, if the similar digit appears in two factors, then you can take only one. So for these two you are taking only one, for these two you are taking only one, for this 5 you are taking only one, and remains is this 3 and this 2. Okay, so if you multiply 120, this is LCM, least common multiplier. Okay, so 120 is divisible by 8, 120 is divisible by 15 and 120 is divisible by 20. But this is not an answer because 120 is not a perfect square, and we have to find out a number which is a perfect square and is divisible by all these three. Okay, we know how to find out. So we have these factors. We have to find out the pairs. Now this is 2 into 2 into 5 into 3 into 2. This is only one pair. So if we have another 5 for to pair these, 3 for this, and 2 for this, so we write it in the paired form. 2 into 2 is this, 5 into 5, 3 into 3, 2 into 2, so that will be 120 into, if 1 5 extra, 1 3 extra, and 1 2 extra, that will be 3600. Okay, and 3600 is a square of 60, or square root of 3600 is 60. So 3600 is a perfect square, and 3600 is divisible by 8, 15 and 20. Okay, so that is the answer. Try to understand, try to solve as many problems as you can. You will find it very easy. Not only this, the whole topic. This is almost the end of the topic for the syllabus purpose. Topic will move ahead for some different knowledge. Okay, if you find any, this is Dr. Bharat Parab. If you face any difficulty or find any problem, write to me in the comment section and I shall definitely solve it and answer it. Okay, good luck for this. Okay, thank you.